I will be discussing linear programming on this video. The first example is a word problem that reads as follows. Juan and James Incorporated produces bass and alto clarinets. Each bass clarinet generates a profit of $40, while each alto clarinet generates a profit of $60. Bass clarinets require 3 work hours in warehouse A and 6 hours in warehouse B. Alto clarinets require 4 work hours in warehouse A and 2 work hours in warehouse B. Both warehouses operate for at most 12 hours each day. Graph the feasible region, then find the number of each type of clarinet that should be produced each day to maximize the company's profits. So what I would suggest that you do before you do anything else is go to the end of the problem and figure out what exactly are you talking about, or what are they talking about? Because your first step is going to be to define your variables. So I am trying to define whatever they're talking about, which is types of calculators. In the end, I'm going to eventually graph. So I am going to define my variables as X and Y. So that means I'm looking for 2 items in my word problem or my scenario that can represent X and Y. If I look at my first sentence, we're talking about bass and alto clarinets. So what I'm looking for next is one of 2 things. It just depends on you. If you want to, you can just go ahead and look for, let's just look for the objective function. Well, if I am in the warehouse business and I'm producing something, I'm trying to find a profit. So let's look for anything that has dollars on it and preferably the word profit. So if I say profit, I know that this is going to be my objective function. So I have a profit of $40 and a profit of $60. I just have to know, well, what does that go with? So the clarinet goes with the $60. I'm sorry, not just the clarinet, both of them are clarinets, alto clarinet, and then the bass clarinet is the one that gives a profit of $40. All right, so we'll come back and I'm going to set up a table, but some people like to highlight, so that's what I'm doing right now. Now that's going to be my profit. Like I said, my objective function, which is dealing with my profit. So the next thing that I'm going to look for is like comparison. When I was reading, I saw that they were talking about warehouse A for 2 things. So I know I'm going to be comparing the bass and the alto clarinets. For the bass clarinet, it requires 3 work hours in warehouse A and 6 hours in warehouse B. Now, if I'm talking about, let's just find another color. For the altos, they require 4 work hours in warehouse A and 2 work hours in warehouse B. So I see something else that jumps out at me. So I'm going to also include that it says that both warehouses operate for at most 12 hours a day. At most tells me I'm going to have an inequality. So I have to make sure I understand inequalities. So go back and look at my graphing linear inequalities videos if you're not clear on inequalities. So let's go ahead and start with our steps. Step 1, and like I said, I'm a table person, so I'm going to draw out a table. It's not going to be neat. I'm just going to let you know for now. So X, I would like to be represented by the bass clarinets. Y is going to be the alto clarinets. And I know that they are both going to have work done in warehouse A and B. Now, these are my constraints. I can, if I wanted to, go ahead and add my profit part to it, but I'm just going to do it in a different color and over to the side. So my profit portion is what is in green because, hey, that's money. For my bass clarinet, let's just go ahead and draw right here. For my bass clarinet, I know that according to what I highlighted, the profit is going to be $40. And also what I highlighted for the alto clarinet is going to be $60. So I know that that's my profit portion. So that's going to equal P. And now if I go back to the pink portion that I highlighted in my word problem, it's talking about the bass. So for the bass clarinet in warehouse A, I am going to have 3 work hours. In warehouse B, I'm going to have 6 work hours. So I'm still talking about bass. Now, when I go to my blue highlight in warehouse A, I'm going to have 4 work hours. And in warehouse B, I'm going to have 2. Now I have to look at my criteria, my constraints. It tells me that both warehouses operate at most 12 hours. So at most is going to be less than or equal to 12. 12 is the most hours I can do each day. So the greater than this side is going to have that bigger, the wider mouth to its inequality. And it said that for both warehouses. So for me, the purpose of setting up this table is because now all I have to do is just go downward to set up my constraints. So these are my variables. My objective, I'm about to write that next. So my objective function is my profit. And that is written as P is equal to 40 represents my X for base, so 40X, plus, and then the 60 represents my Y for the alto. So that's going to be important to know what I'm aiming for. This is my objective function, which is my profit statement, basically. So I have that. The next item is going to be my constraints. And I said the purpose of me even setting up this table was to determine my constraints. So my constraints will be that I can only do 3 hours for the bass in warehouse 1 and 4 hours for the alto, less than or equal to 12 hours. And then if I go to my second column for warehouse B, I have 6X. Remember, I'm talking about this row. And then I add down 2Y. I'm now talking about this row. And the most that I can do is 12 hours. So less than or equal to 12. Now, what most students will forget, and sometimes I do, you can't produce a negative item. So if you are not specifically told how many bass clarinets that you're producing or how many alto clarinets you're producing, the very minimum that you can have is 0. So you're going to always put this additional constraint in there unless they said something like you must produce 100 bass. So then you would do 100. So basically, you're always going to have a constraint that has X on a side by itself and Y on a side by itself. If it's not given, then you're going to set it up as 0. So those are my constraints. Now, my next step for me, this is what I do. I find my X and Y intercepts and I base it off of those constraints. So those constraints that were here. Now the X and Y intercepts, well, the X is greater than equal to 0 and Y is greater than or equal to 0. That's going to end up being your origin. But as far as the 3X plus, I'm just going to go ahead and substitute 0 in for my Y. And when I do that, I end up with the coordinates of, if I put a 0 in for Y, which is what I just did here, then I would solve for X. And when I do that, X becomes 4. So that's finding that X intercept. And so now to find my Y intercept for this same constraint, I would replace the X with 0. And now I'm solving for Y. 3 times 0 is just 0. 4Y is less than or equal to 12. I solve for Y. So therefore, if X is 0, Y will be 3. This is going to be my first line that I graph. And now I'm going to go to my second constraint, and I'm going to do the same thing. So I have 6 6x plus, and I'm going to replace that y with 0, less than or equal to 12. When y is 0, x becomes 2. Checking my math here. So 12 divided by 6. And now I'm going to substitute a 0 in for x and solve for y. When x is 0, 12 divided by 2 is 6. This is my second line when I go to graph. So I did this first. The next thing I do is I'm going to put those in slope-intercept form so that I can find my slope. All right, so I have 3x plus 4y is less than or equal to 12. To put this one in slope-intercept form, I'm going to subtract 3x on both sides, which leaves me with 4y is less than or equal to negative 3x plus 12. Divide everything by 4. Y is less than or equal to negative 3 over 4, x plus 3. My slope is negative 3 over 4, and my y-intercept in the form of a coordinate is going to be 0 as my x, and then 3. I'm getting that from here. Again, if you don't remember how to do this, go back to my graphing linear inequalities video, and I walked you through how to put your work in slope-intercept form. Next one is 6x plus 2y is less than or equal to 12. And again, these are my constraints that I'm working with. Putting it in slope-intercept form, which is that y equals mx plus b form, I am going to subtract 6x on both sides. 2y is less than or equal to negative 6x plus 12. Divide everything by 2, and I have negative 3x plus 6. My slope this time, if I put it in fraction form, is negative 3 over 1. And my y-intercept, if I put it in coordinates, is 0, 6. I'm going to take this information and I am going to now graph, and then I'm going to verify my point of intersection, because with my ruler, I might be off a little. So let's just go back to the points that I have here. Let me grab these for my lines. Copy that. And hopefully it'll paste correctly. All right, so for my first line, I said that I wanted to go over 4, 0. Might help if I actually select a pen. And 0, 3. Take my ruler, and I am going to draw a solid line, because when I looked at my constraint, it was less than or equal to. So I also wrote it here. The only thing is I changed this because I'm going to show you how to use systems. But if you were to go back up and look at it, this is what it originally was. Less than or equal to means that it's going to be a solid line. And typically teachers will go ahead and shade like below. I'm not going to do that. I'm only going to shade once I find my feasible region so that it's not really messy. So I know here is my first line. The second line is going to be 2, 0 and 0, 6. Again, I take a line and I'm going to connect those points. And I'm looking for a point of intersection. What I see is it's not exactly on a whole number. So I have to try to figure out, and what I was going to say is just try to use your slope. So like from 0, 6, go down 3 and then over 1, or for 0, 3, go down 3, go down to go down 3 and to the right 4 to see if you can get to this point. But since it's not a whole number, let's go ahead and use our systems of solving systems of equations. So that is why I changed these to equal signs. So what I want to do is I want to try to, for me, I'm going to get rid of the x's first, but you can get rid of the y's if you want to. So I'm going to try to get rid of the x's, and in doing so, that means that I have to multiply the entire first equation by -2. Why? Because I already have a 6x. I need the opposite sign or the inverse. So negative 2 times 3 is going to give me negative 6x, negative 2 times 4. So I'm basically just distributing. And that's going to give me negative 8y and then negative 24. I no longer need that information. I was trying to get rid of my x's. I was successful in doing so. So now I'm left with negative 8 plus 2, which is negative 6y, equals 12 plus negative 24, which is negative 12. And then y is negative 12 divided by negative 6, which is 2. I take this 2 and I can substitute it in. It does not matter which one of these that I use. I'm just going to choose the one, the top one, this one. So I have 6x plus, instead of 2y, is now 2 times another 2 is equal to 12. And I'm solving for x this time. So 6x plus 4 is equal to 12. 6x is equal to 8. And I see that this is actually going to be a fraction. It's going to be 4 over 3. When I'm graphing, I try to put it in a decimal form. So that's approximately 1.3. So this is telling me that my coordinates are going to be 1.3 and 2. This was my x and this was my y. So if I go over here, 1.3 and about 2, yes, that's about right. So that is a point that I want to keep up with. What I am looking for is the region where it is overlapping, and that's what I'm going to shade. So what I can't forget is I already did my lines, but in my constraints, I had x is equal to 0, x is greater than or equal to 0, and y is greater than or equal to 0. Well, technically, that's my origin. That's 0, 0. So I'm going to go ahead and put a point there. And I can clearly see that I have a region here where this intersecting point was. That's why that's important to find that. That is now supposed to be shaded in. Because again, I didn't shade the other part. Like some teachers shade everything right away. I don't. I wait until the end. That's a little too much. That's too heavy. Okay. I went outside, so I want to make sure I stay in here. This is the only region that I'm trying to shade. All right, so I'm looking at only those points. I do not need to worry about this point or this one because it has nothing to do with that shaded or feasible region. I'm only working with the points that are connected to that area that's shaded. That is going to take me to my next step. So I need to keep up with my objective, which is my profit. This is what I wrote out in the beginning. So I'm looking at, I had let me see if I wrote it down so I don't have to scroll back and forth. 0, 0, and then I also had 2, 0, 0, 3, and then we just found 1.3 and 2. So again, those are the points that connect that shaded region. You need this profit, I keep saying profit statement, which is what it is. My objective function is going to be 40 times whatever x is plus 60 times whatever y is. And that's going to help me determine my maximum and minimum profit. And I'm going to just bring that 40 down each time, the 60 down each time. And the only thing I'm going to do is replace what's inside of the parentheses with my ordered pair that I have over to the left. And then just do the math. So again, I'm talking money. So I'm looking at my ordered pair. This is my X, this is my Y. So I have 0, 0. Well, I already know that's going to go away, which results in 0. 2, 0. This is going to go away, 80. 0, 3. 40 times 0 goes away, 180. And then finally 1.3 and 2. If I simplify this is going to be 52 plus 120 for a total of 172. Now, had this been a decimal, because you can't produce a partial clarinet, then I would have rounded down. But it's not a decimal, so we can go ahead and proceed with it. So what I was trying to do is determine the maximum profit. So I have to look at my outcome, and I see that this is my maximum. What you need to do now is put it in sentence form. So what your X and your Y represent are the different clarinets. So in order for, let me write this out here. So in order to maximize, excuse my writing, profit of $180, that's what this is. Juan and Jane's Inc. will need to produce 0 bass clarinets. Remember, we said that that's represented by X, and 3 alto clarinets. That's where they will make the most money. And that's what each of those items stand for. So X stands for your bass clarinet, which you established early on, and Y stands for your alto clarinet. All right, so that's how you start. Well, this is how you do linear programming. So I'll go all the way back to the beginning, so you can just kind of take a look at the items that were highlighted, and maybe that'll help you out. Pause, fast forward, whatever you need to do so that you can get this in your head, okay? All right, you guys, thumbs up, please. Subscribe. Have a great day.